Methods of charging. So the first thing we're going to talk about is charging by induction. For example, if you bring a positively charged object near an uncharged conductor, the electrons in the conductor say, "Ooh, yay!" And so they head towards it and the charges become rearranged. Now, this works with negatively charged objects too, and I happen to have a picture in that circumstance. So here you'd have a negatively charged rod, like a Teflon rod, and so all the electrons in this case run away. The metal sphere still has no net charge, but it's now essentially become polarized. So if you then divided this sphere, you could actually then create an object that has been charged. So some objects can also be charged by touching each other. This only works with conductors, where the electrons are free to move through both objects. So if a charged conductor touches another conductor, whether it's charged or not, the electrons will move to spread out as much as possible, leading to a roughly even distribution of electrons over the surface of the combined objects. You can use an electroscope to detect electric charge. So here's an example of how you might walk through doing this. Okay, if you have a neutral electroscope to begin with, the two leaves at the bottom are both neutrally charged, so there's no electrostatic force whatsoever. So if you bring a charged rod near the top, you get an induced charge in the connection between the top and the leaves at the bottom. Now in this case, both the leaves at the bottom are positively charged, so they repel. If you then touch the top of the electroscope with the rod, in this case we're going to assume that this is a conductor that touches it, so the charge actually transfers into the rod, leaving the electroscope with a net positive charge, and those leaves are still spread. If you then brought a negatively charged rod, conductor or insulator, so a Teflon rod would work here, your charged electroscope is actually going to have some of those positive charges, or the holes, like Dr. Hafner talked about in his lecture, move up towards the negatively charged rod. In reality, you just have extra electrons that have transferred to the bottom. The net result is that the leaves at the bottom are less positive, but they're still repulsive, but they are spread apart less than they were previously. Grounding is something that becomes especially important when we talk about circuits, but it's when a conductor is physically connected to earth or any other large conductor by a wire or other method. A charged conductor will lose its net charge when grounded. A polarized conductor will gain a net charge after being grounded. This is like polarizing it and then cutting it in half. A Van de Graaff generator usually creates a positively charged dome. The big one in my classroom does, but I have two smaller ones that create a negatively charged dome. So it all depends on which way the belt is set up to transfer it. So this is what we looked at in class, and here's a picture of how it works.